All right, the motion of a North Pole magnet from above the page changes the magnetic field by 2.7 teslas inside this square. A current flows clockwise in the loop. Ooh, clockwise. Okay. Let's look at the direction of this. Okay, so we've got this magnet, right? And we don't know what the poles are. But we know, here, I'll draw it properly. And we know, though, that this, okay, we don't know which way, oh, the North Pole, sorry. We do know that's North Pole, we do know that's South Pole, right? But we don't know which way it moves. But whatever way it's moving, it's making the current flow clockwise. Well, if the current flows clockwise, if it's going clockwise, then that makes the top part of this loop, above the loop, a South Pole, and below the loop, a North Pole, okay? Out of the page, it'll be a South Pole. Below the page, it'll be North Pole. So if you're making a South Pole, it must be that the magnet is receding, okay? So it must be that this magnet goes that way, okay? So we know that it receded, it went away, because it's creating a South Pole out of the page, which would only lure this thing back. So it only makes sense that this thing has to be retreating, right? Okay. And now we can figure out, what do we want to know? Oh, how much time, right? So EMF is going to be NBA, and it's going to be the change in magnetic field, right, over T. So therefore, the time is going to be N delta B A over the EMF. So the time is, I assume there's just one winding here. Is that right? Yeah. It's just a single loop. Okay. Current. Oh, we don't know the EMF. Oh, let's figure that out. Okay, so V is IR, right? So we know that 22.1 amps flows, right? And the resistance is 0.26 ohms. So 2.1 times 0.26. Let's see, did I get that right? Yes. Is 0.546. So the voltage, or the EMF, equals 0.546 volts. That's a 4. Okay, so now we're ready. So we've got one. Our change in magnetic field is 2.7 teslas. Our area is 0.82 squared. And then we can divide that by 0.546 volts. NBA. Yes, I think this might be the right answer. Okay, so 1 times 2.7 times 0.82 squared divided by 0.546. And that's 3.325 something, right? 49 seconds, so 3.33 seconds. Okay. 546 millivolts, right? So the voltage is, sorry, the voltage is 0.546 volts, or 546 millivolts if you want to, right? And it receded. All right, I have to go to a meeting.